functions f and g are such that f of x is equal to 3x minus 1 and g of x is equal to x squared plus 4. Given that fg of x is equal to 2gf of x, show that 15x squared minus 12x minus 1 is equal to 0. My first step is to work out fg of x and 2gf of x separately before putting them equal to each other. To work out fg of x, as we've got two functions, we know we've got a composite function. We always start by adding an extra pair of brackets. We always work inside, then out. So leaving the outside function alone, in this case f, on the inside we've got g of x. Well, g of x is simply just copying our function g of x, which in this case is x squared plus 4. Whatever we get, this now becomes the input for our outside function. So now into the function f, every time I see the letter x, x is now going to be substituted for x squared plus 4. So on the right-hand side, 3x in algebra means 3 times x. Hence, we're going to have 3. X we now know is x squared plus 4, as we've got two terms placed inside a single bracket. And we've still got the negative 1 on the end. Expanding my single bracket, whatever's outside, we multiply by each term directly inside. So 3 times x squared gives us 3x squared. And 3 times 4 gives us 12. And I've still got the negative 1. Simplifying, collecting like terms, I've still got the 3x squared. I know 12 subtract 1 will simplify to give us plus 11. Now working out 2gf of x. Again, if I've got two functions, I know I've got a composite function. Again, we always work inside then out. So on the outside, leaving the 2g alone for now. On the inside, I've got f of x. So f of x is just simply 3x minus 1. This now becomes my input to my outside function. As on my outside, I've got 2g. Well, I know 2g in algebra means 2 multiplied by g. So I'm going to multiply my answer at the end by 2. So on the inside, first I'm going to work out g of 3x minus 1. So into the function g, every time I see x, x is now 3x minus 1. So on the right-hand side, x squared in algebra, we know means x multiplied by itself. As x is now 3x minus 1, therefore I'm going to have 3x minus 1 multiplied by another 3x minus 1. And I've still got the plus 4. Expanding my brackets on the inside. When expanding double brackets, I can apply the FOIL method. So multiplying the first term each bracket together, well, 3x times 3x gives you 9x squared. O for outside, multiply outside terms together. 3x times negative 1 gives you negative 3x. I for inside, multiply my inside terms. Negative 1 times 3x gives you negative 3x. And L for last, we know negative 1 times negative 1. And negative times negative gives us a positive. So negative 1 times negative 1 gives us plus 1. And I've still got the plus 4 on the inside. Collecting like terms on the inside, I know I've got 9x squared and no other term ending in x squared. So leave 9x squared alone. I've got negative 3x, subtract another 3x. Well, negative 3x take another 3x will simplify to give us negative 6x. And collecting my number terms, well, 1 add 4 simplifies to give us plus 5. Now multiplying by the 2 on the outside. Whatever's outside, that will multiply everything inside the bracket. So the 2 is going to multiply each term inside. So 2 times 9x squared will give us 18 lots of x squared. 2 times negative 6x will give us negative 12x, and 2 times positive 5 will give us plus 10. As I was given that fg of x is equal to 2gf of x, therefore I can just put them equal to each other. As I want my quadratic to equal to 0, I've currently got positive 18x squared on the right, and I've only got positive 3x squared on the left. As I've got more positive x squared on the right, therefore I'm going to bring everything across to the right. So the opposite add 3x squared, therefore is subtract 3x squared from both sides. Likewise, the opposite add 11 is to subtract 11 from both sides. On the left-hand side, 3x squared take away 3x squared will cancel, and 11 take away 11 will cancel to leave us with 0. On the right-hand side, I know that 18 lots of x squared take away 3 lots of x squared will simplify to give us 15x squared. I've still got the negative 12x, and 10 subtract 11 gives us negative 1.